Welcome. In this lecture series, we'll be looking at an introduction to cloud computing, and we'll focus a little bit on the aspects that distinguish cloud computing from previous generations of distributed systems. So first of all, there's a lot of hype around cloud computing. Several forecasting agencies which forecast market trends for different markets have said that cloud computing is large and it's only going to grow, perhaps exponentially. Gartner, which is one of the most popular forecasting firms, said in 2009 that cloud computing revenue would exceed $150 billion by 2013, and that it would represent a significant fraction of IT spending by 2015. IDC in 2009 said that in the next 5 years, spending on IT cloud services would triple and would reach several tens of billions of dollars. Forrester said that cloud computing would go to $240 billion as an industry by 2020. And it's not just an industry. Several governments have also started relying on cloud computing, including fedbizops.gov, which was set up many years ago by the federal government. So obviously there is a lot of hype, but then the question is, what exactly is cloud computing? Well, there are many cloud providers, as I'm sure many of you might have heard of. One of the most popular cloud providers is AWS, or Amazon Web Services. There are also other providers here: Microsoft Azure, Google Compute Engine, and there are a whole bunch of other companies including RightScale, Salesforce, EMC, Gigaspaces, Tengen, DataStax, Oracle, VMware, Yahoo, Cloudera, and hundreds of more companies that are too many to mention here. So let's just focus on the AWS portion. AWS offers a variety of services. Three of their most popular services are called EC2, S3, and EBS. EC2 is an elastic compute cloud, which provides you computing services. S3 is a simple storage service, which provides you the ability to store data so that you can access it from anywhere in the world. And EBS is elastic block storage, which is essentially volume storage that the EC2 instances can access while they are running. So there are two categories of clouds today. They are either a public cloud or a private cloud. A private cloud is one that is accessible only to special privileged employees or personnel. For instance, if you're working in a company X and the company X has a data center or a cluster or a cloud which is accessible only to the employees of the company, that's a private cloud. It is not openly accessible. On the other hand, a public cloud is one that can be accessed by anyone, anywhere in the world, as long as they have a credit card and are willing to pay. Private clouds, for instance, also include, the first category also includes you buying a data center or a cloud and running it yourself. That's your own private cloud, obviously. So among public clouds, the ones that are openly accessible, as I mentioned, there are a couple that are fairly popular: the Amazon AWS services, Google Compute Engine, and the Microsoft Azure tend to be popular. The AWS and Azure share a lot of traits, so I'll just focus on AWS here. The S3 simple storage service allows you to store arbitrary data sets, and you pay per gigabyte month that you store. There are no upfront costs. The Elastic Compute Cloud once again allows you to upload and run arbitrary OS images. Essentially, these are virtual machines, or VMs, and you pay per CPU hours that you use. So if you use, say, 5 VMs for 1 hour each, all at the same time, you'd be paying for 5 CPU hours. And similarly, the other services that AWS or Microsoft Azure might offer are also priced accordingly. There are variants of this, of course. Google App Engine or Compute Engine offers the ability to develop applications within their App Engine, and then you upload the data that would be imported into their format, and you run your application. So for instance, you could use these to host your own web services. You could use these to host your data so that it is served out, or you could host these to run your own computation that you might want to run. So cloud computing is attractive to customers because it allows them to save both time as well as money. Eli Lilly, which is one of the largest customers of AWS, reputedly, for instance, has been benefiting from the ability to bring up new servers fairly quickly. Earlier, they reported that it used to take 7.5 weeks for them to deploy a new server. This would involve them setting the specs for the server, then actually purchasing it, and then going through the purchasing process. The server comes in, then they set it up, and they install the necessary operating system and software, and all of this took several weeks. Now they can bring up a new server in around 3 minutes, and a 64-node Linux cluster in 5 minutes, while it was taking months earlier. This, of course, saves them time. It also saves them money because they can save the costs that they might have otherwise had to pay the sysadmins. GlaxoSmithKline reported that they saved about 30% by moving to the cloud. Jim Schwartz from the CIO of Seabase said that they've been saving $2 million since 2006, and this is only going to increase. And as a result, it's not surprising that hundreds of startups across Silicon Valley are leveraging some of the cloud providers who I mentioned, and a variety of other cloud providers as well, rather than buying their own machines. But once again, this brings us back to the question of what exactly is a cloud for us technical folks who want to understand the deep, detailed aspects of cloud computing. We'll discuss that in the next lecture.